the previous video I have posted the part 1 of the basic operational concept, where you studied what are the things, what are the basic operational units that are in the processor, and I have explained each one in detail. Please, I will give that link in the description box. Please complete the part 1 and then come to the part 2, so that it will be easy for you all to understand. And then let's get into the concept. Before that, I would like to request you all to please subscribe to my channel, and do share this video to your friends, so that it reaches the maximum number of people, and they will also be able to understand the concept easily, and it will be easy for you all to prepare at the last minute of the exam preparation. And also, don't forget to like my channel. So let's get straight into the concept. So in the previous video, I have explained you all the structure of this box. So let's get into an example. What all the things that happens inside the processor, we will be learning in this video. So an instruction, you all know what is an instruction. Generally, an instruction is something like a superior person gives to to his slave. Assume the master slave concept. Master will give the instructions or commands to the slave. So in English terms, this is an instruction. So similarly, what is an instruction is, it consists of two parts. One is operation code. Operation code is nothing but it signifies whether it is an addition, subtraction, multiplication, or any other operation. Okay, I will repeat once again. It signifies whether we are going to do an operation, whether we are going to do an addition, whether we are going to do an subtraction. This is what an operation code tells. And what is an operand? Operand is like for example, see this instruction. In this, r naught is an operand, because it will contain the data required for the instruction. Operand is something that will contain the data required for the instruction. So the data or operand are stored in the memory. So here I would like to make the concept easier for you all. First, it is the memory. We will it is like our brain, right? We store whatever we see here and all those things in our brain. So memory stores. Remember, memory stores. Like, assume brain, what your brain does, it stores, right? Similarly, memory is something that stores. So what it stores data and operand. Simple, easy thing. And next point is, an individual instruction are brought from memory to the processor. So assume you are thinking something like, you are thinking like you have to take a book and place it beside you. So the data is the book, so you have to place the book beside you, is the instruction that you are giving to your brain, right? So you're bringing the action, you're bringing the thought that is in your memory to the processor. Like, let's assume the processor is the action. So my thought is like, I have to bring the book beside me. So that thought is in my brain. Similarly, the data is in the memory, and you're bringing that into the action. So you're moving the book. Similarly, you're bringing the data from the memory to the processor. Simple, just simple, don't get confused. Then the processor performs the specified operation. So you're thinking in your brain, you have to move the book beside you, and you are moving it, and you are doing some action. So the action is nothing but the processor performs the specified action. You think and make it into the action. Similarly, the processor will do the specified operation. It is not the memory. If you just think like, I have to just move the book, it is not going to happen. You have to get into the action. Similarly, from memory, you bring the data to the processor. I just want you to remember these 2 points that I have given here. Memory will store. What it will store? It will store the data. And so you are bringing the data to the processor. In the processor, what happens? In the processor, operation happens. Simple. This 3 point is more than enough. Okay. So initially, I have given this example that you can see that I have highlighted. This instruction is an addition operation. I have told you all initially, operation code signifies or tells us what operation we are going to do. It can be addition, subtraction, multiplication, and or etc. Like, there are so many operation code that you will be seeing in further concept. First, let's go with the simple one. So following steps to execute an instruction, what happens? So you fetch an instruction from the main memory into the processor. So it is not just only the data that gets stored in the memory, it is also the instruction that gets stored in the memory. You just don't remember things, you also remember memories, right? The thing that happened in your childhood, the thing that happened when you were in fifth or sixth standard, all those things you remember, right? You just don't remember only like a book, pencil, paper. That is the data. You also remember the memories, which is like, imagine, like, assume your memories are instructions are also stored in the memory. So you bring the instruction from the main memory to the processor, as I told. So here the thing is, it is not only the data, instructions are also stored in the memory itself. Understood? Okay, I hope the concept is clear. Let's move into the second step. Second step, what you do? Okay, right, you bought the instructions to the processor. What happens in the processor? Operation happens. Before that, what memo, or like what the, like I will tell you all. First we'll read this line so that we'll understand. Fetch the operand at the location A from the main memory into the processor. So we are talking with respect to this example that I've given here. So location A, what is this location A? I forgot to tell you all. The location A, lock A, you can see in, like I've given lock A. So abbreviation of lock A will be location A. It is some location in the memory. Location A. Just assume location A as a box. Okay. Inside a box, there is some operand. Operand consists of some data. Simple, just simple. Don't get your brain like don't get so much confused. Like you are in some location. Which location? Some address you stay in. In that address, there are so many houses. Operand. Location always consists an operand, and it can also contains the instruction. It is secondary. In that location, you have an operand. Operand is nothing but a data. Simple. It contains data. So fine. Okay, fine. We are in the step 2. What we did, we went to memory. Like we bought the instruction into the processor, and what we did next, after that comes the location A. Location A. In location A, you have an operand that is there in the main memory. That thing also you are bringing into the processor. So let's see what happens in step 3. In step 3, you have R naught, which is an operand, means the data. Like operand, add the memory operand to the content of register R naught. I said initially, like R naught contains some data, so contains something that is added with the operand that was initially fetched from the memory. From memory, you brought it into the processor, which was in the location. In the location of the memory, there was an operand that you brought into the processor, and in the processor itself, there are n general purpose register that I have told in the part A. So that you have brought into the, that is already there in the general purpose register. R0 to Rn, I have told you initially. R0, there is some content that is added with the operand brought from the memory. Easy. And we had those things, and the result is stored in R0. Okay, y'all can question me why just it is R0, not why I'm not storing in the location A. So you can store either in the location A or in R0. You can store in anything. Destination, there is something called destination register. So these both are source register, but there is something called destination register. Only either of the two can be the destination register. You can like, it depends upon the computer. It stores the result in either of the operand. Okay, fine. Let's go into how the instruction, like with this example itself, I have explained most of the steps that will take place in the takes place when the instruction is executed. So here I have given another example. Here the difference is, there are two instructions. Initially there was only one instruction. Here there are two instructions, and same thing. Here I have told you all, no, like see, load is also an operation code. So this two, like see, first you're loading the R0 R1 in the location A. You're loading the R1 in the location A, and then what you're doing, R0 and R1 you're adding. So what is R, like how to explain you all? Okay, fine, because I don't want to make this thing very complicated. I have to explain you all very easily so that you'll understand. Wait a second. Okay, so first thing, what you do, load. What you're loading? So R1, whatever is in the location A, there may be some data. That what I'm doing, I'm bring that content, whatever is there in location A, I'm bringing it to R1. Done. So R1 now contains the data that was there in the location A. Now next instruction is add. Add is add R1 comma R0. So what happens now? The result will be stored in R0. So R0 is equals to R1 plus R0. Simple. And the result will be stored in R0. Initially, whatever was there in location A, I brought it into R1. Then what I did, content of R0 and content of R1, I added. And I stored the result in R0. Simple. Okay. Most of the thing would have been understood by this time with the things, whatever I explained, also be stored in the PC. What if the program is initially starting? First instruction will also be stored in the PC itself. Okay, fine. Next I have told about IR. IR will, what does IR do? It stores the instruction. Stores the instruction to be executed. Executed currently. These two things, I hope you all understand. I want you all to remember these two things. Then fine. Okay, these two things you all remember. And also don't forget about the MAR and MDR, which is very important here. MAR and MDR. Here it is. Okay, fine. So address of first instruction gets loaded into PC. So the first thing that we have to remember here is about PC. And then what happens, we bought the instruction into PC, the content of PC are transferred to MAR, where what happens in MAR, we have the address to be fetched and executed. So then after the address is loaded into the MAR, which is memory address register, control signal will be generated. Control circuitry will generate signal. Fine, still here I hope you all understood. So next, after generating the control signal, what happens, it will wait for some time. After waiting for some times, first instruction will be read from the memory. Now comes the memory. What will be read? Instruction will be read from the memory. Fine, I hope you all understood still here. After reading the instructions from the memory, what happens? So now I have instruction. Instruction is what I initially said, data and memory will be stored in the data and instruction will be stored in the memory. Now that should be bought into MDR, which is memory data register. So I have my instruction. What happens next? It will be transformed to IR. IR is instruction register. I told you all it is important. It stores the instruction to be currently executed. Now what happens in IR? So I have everything. I went to PC. First instruction I bought to PC. Then I loaded into MAR. Then the control signal generated. I ran to the memory to bring the instructions to MDR. Then from MDR I put the instruction into IR. Finally I have the instruction in the IR. Now this instruction will get decoded and executed. That's all you have to remember. I made it so simple for you all. So its address is placed into now this 4 is different, and this thing now I'm going to explain it different. To fetch an operand, its address is placed into MAR. Now whatever story I've told y'all, katam, it is over here because this is the story of instruction. Now I've read the instruction. So in instruction I have an operation code and opcode that I've told, opcode and operands that I've told you initially. So now what I want, I've read what instruction it is and I want the operands to be brought into the processor for further execution. So again I will start from initially. I will start from the initial step, that is I will start from the MAR, that is address, because I know the address of the data where it is stored. So I come to MAR and I will put the address of the data that I want for my instruction to be executed, and again control signal will generate. Okay, again the control signal will be generated and it will wait for some time, and the operand will be transferred from operand will be brought to the memory. It will be brought to the memory. From memory it will be brought to the MDR. Okay, but this time it is not instruction. It is what? This time we are bringing the data, not the instruction. Okay, I hope you all understand. This time we are bringing the data, not the instruction. Okay, fine. This time we are bringing the data. So we brought the data into the MDR. Then this time it is not transferred to IR because IR will hold the instruction. Okay, but it is the data. So what I will do, I will put it into ALU is something where arithmetic and logic operation is going to be performed. Likewise, required operands, like there can be many number of operands that we require for the instruction to be executed. So like that, many number of instructions will be fetched into the processor. Finally what happens, ALU will perform the desired operation. Whatever operation is needed, ALU will perform that if the result of this operation is to be stored in the memory. So there are some instruction, the result should be stored in the memory. There are some instruction, the result should be stored in the general purpose register. It all depends upon the instruction. If it is to be stored in the memory, I will send it back to the memory and I will tell you stay there, you must stay there. So I will store the result in the memory itself. So that will be, then the result is sent to the MDR. So backwards, see here I have explained it forward. What happens for storing the data? It goes backwards. So the data to be stored will go to MDR, and the address of the location where the result is to be stored is sent to MAR. So I know the data, and I will put the data in the MDR, and I know where in memory which location my data is to be stored. I know the address, so I will also send the address. I will put that address in MAR, and write cycle is initiated. Control signal will, when fetching the instruction or data from the memory, I will generate and read signal. But when I want to store the data, it will generate a write cycle. Am I making it clear? I hope that I'm making it clear. Please pause the video and rewind whatever I'm telling you. Okay, now write cycle. One second. Write cycle is initiated. After write cycle is initiated, what happened? At some point during execution, content of PC are incremented to point to next instruction in the program. Done. That's all. So after the first instruction, while the first instruction is decoded and executed, at that time itself, the PC will point to the next instruction. Okay, I hope that I've made the concept clear. First PC, then whatever the address in PC, I bring it to MAR, and then I will generate a signal which is read signal, and read signal will go to memory, and it will read the instruction, and whatever the necessary data is, it will be sent to the MDR, and from MDR it will be transferred to IR, and instruction will be decoded and executed there. Finally, for data, similarly, the same thing will happen. Instead of storing it into the IR, we directly send it to ALU so that operations are performed. To store the data, I go backwards. Like I stored, like first I put it into MDR where data gets stored, data is sent, and then I know the address. I put the address in MAR, and I send the MAR address to the memory. Like I issue a read signal. Then after that, the data will be stored in the memory, and finally PC will be pointing to the next instruction to be executed. That's all is the concept. Hope it is I hope you'll understood. If any doubt, please let me know in the comment section. I will always be there to help you all. So this is the diagram that you have to remember, and then each thing I have explained more than 5 times: what PC does, what IR does, what ALU does.